For every action, there is an equal and opposite reaction. Since 1687, this sentence has served as the most recognizable rule in the history of physics. Consider a horse harnessed to a heavy carriage. The horse pulls forward with 100 newtons of force. According to a strict literal reading of Newton's law, the carriage pulls back on the horse with exactly 100 newtons. On paper, these forces cancel. 100 minus 100 leaves a net force of 0. If every force in the universe were instantly and perfectly neutralized by an equal counterforce, the entire cosmos would grind to a permanent standstill. All movement would be a mathematical impossibility. Movement is obvious, so we know the physics isn't broken. The error lies in our interpretation. The words action and reaction imply a sequence, a cause and an effect, which hides how forces actually function in nature. In physics, a force cannot exist in isolation. An object cannot simply have a force. It must interact with something else. When a player kicks a soccer ball, the foot applies force to the ball. At the exact same microsecond, the ball applies identical force back. The paradox disappears because forces act on different objects. The action vector belongs to the ball. The reaction belongs to the foot. They cannot cancel each other out. True cancellation only occurs when multiple forces act on the same object, like a book on a table. Despite what the names imply, there is no delay. Action and reaction are two names for a single, perfectly simultaneous event. Forces are simply the currency traded across the boundary between two distinct things. Movement happens because this trade changes the state of both objects involved. This leads to a deeper question. Why does the universe insist on this perfectly balanced trade every time two objects interact? Newton's third law sits atop a much deeper, more fundamental architecture of the universe. Forces are the visible results of a hidden law, the conservation of momentum. Driven by Noether's theorem, the laws of physics are identical everywhere in space. Because location doesn't change the physics, total momentum remains an absolute constant, here or a million light-years away. Newton's third law serves as the macroscopic bookkeeping that keeps the universe's underlying ledger, this conservation of momentum, in a state of perfect balance. Because the uniformity of space is universal, these same momentum trading rules apply to stars and planets. The sun pulls on the Earth, but the Earth pulls on the sun with the exact same amplitude. Because they are trading momentum, neither object is perfectly static. Instead, they orbit a shared center of mass called a barycenter. We utilize this same trade to navigate the void. In the vacuum of space, a rocket has no ground or atmosphere to push against to gain speed. It creates motion by pushing against its own fuel. By blasting exhaust gas backward, the rocket trades momentum with itself, propelling its own mass forward into the dark. This specific mechanism, the boundary interaction between two bodies, is the only way humanity can move through the vacuum of the cosmos. This law is frequently taught as a simple observation about consequences. In reality, the math describes a deep physical interconnection between every object in the universe. Because momentum must always be conserved, total isolation is physically impossible. Everything that exists is defined by its relationship to something else. You cannot touch the universe without the universe touching you back.